My first impression, and that is also the last impression, it is just absolutely amazing. I get to actually collaborate on these fantastic specimens.
I developed expertise, knowledge about medical imaging, particularly using light, optical imaging, and then translated that across into heritage work. In discussion with the Grant Museum, it was clear that their iconic object is the jar of moles, and scanning the jar of moles to count them seemed like a really nice, self-contained student project.
The difference between X-ray and CT is they both use the same types of ionizing radiation, but an X-ray image is a two-dimensional projection, whereas CT scanners can actually generate such projections from all around the object.
And once you've got that data set, you can use computer programming to work out what must be happening inside the object, so it gives you a full three-dimensional structure of bones and soft tissue and so on inside the body.
We started off with moles, I believe, and we were delighted to see that you could actually see the little rib cages of the moles, and we knew at that point we were going to have something for our student to work with.
The main highlight for me was seeing the images appear on the screen as they came off the system. They didn't need any additional processing. You see the little feet appearing to move as you scroll through the images, and that was great to see.
It is actually quite a challenging scenario because these specimens are in glass jars, interact very strongly with the radiation. Some of the really soft or really small objects like cicadas were actually too small for us to comfortably image. But also the anoles, they don't really have much of a skeleton to go on, so they were very, very difficult to see. Different tissues, for instance bone or the soft tissue components, they interact differently if you use different parameters. So if you can take the same image using different parameters, we can actually extract more information from that.
At the very end of the day, we thought, okay, we'll try the starfish. You know, it's an invertebrate. It's probably not going to work out too well. It was absolutely the most beautiful one that we did that day.
So it's quite common in conservation for X-rays and CT scans to be used to examine and really interrogate the material nature of objects and help us inform treatments that we would possibly employ. So for me, it was wonderful and really enriching to see.
The specimens and samples that we have used here were the closest to actual human beings that the scanner has actually seen. In the very first session, it became more than just an imaging session. It actually became an engineering problem. How can we actually image these rather challenging subjects? And that will have bearing on us engineers because it allows us to develop new techniques, apply for funding to do so potentially, advance what our collective technologies in the department are, and that will eventually, hopefully, actually lead to better imaging in clinic.
Of all universities, I think UCL is really well positioned to investigate links between science and museums. You know, we've got 4 or 5 really excellent museums and all kinds of science departments doing all kinds of stuff. I think this was quite a well-pitched student project because it involves, you know, iconic objects. It's got aspects of data collection, and then once we had the data, in terms of AI, we really left the student to themselves to do the analysis.